So for this question, we have a variable expression over another variable expression, and most important, or more importantly, we have two terms in the denominator. So if you have two terms in the denominator, there's just no way out of this thing. You have to go through the quotient rule. So our top function is going to be equal to the x squared, and then the bottom function will be the x squared plus 10. So taking, I don't know why I wrote t squared there. So the top function is x squared, bottom function is x squared plus 10, and then our top function's derivative will be 2x, and then our bottom function's derivative will also be 2x. All right, so we are going to crisscross them and subtract the diagonals. So we start, B is for beginning. That's very important that you always start with the bottom. So you start over here at the bottom, take it times the derivative of the top. And again, when you plug into the quotient rule, that is you taking the derivative. So as soon as you plug into the quotient rule, that's your y prime now. And you do want to be careful here. You have two terms for the bottom, so you're going to put parentheses around that and say it's x squared plus 10 times the derivative of the top, which will just be 2x, minus, and then this diagonal. So here you have a 2x times x squared all over the bottom squared. So that's going to be x squared plus 10 quantity squared. Now, at this point, there are two ways of approaching this question. Probably the easiest thing to do is to notice that you have this minus sign, and that splits you up into two boxes. So you can look before the minus sign, and you can look after the minus sign, and you can factor out a GCF. So once you plug into the quotient rule, then you can either remove the parentheses, which would be pretty straightforward to do with this question. I would just distribute the 2x, or you can factor out the GCF. And just for practice here, I'm going to go down the road of factoring out the GCF. So if I look at both of these boxes before and after the minus sign, I see that there is this common factor of 2x and 2x here. So if I take out that 2x, I will be left over with, so from the first box, this 2x is gone, so I'll just have x squared plus 10. And I can drop the parentheses because those parentheses are just raised to the first power. Minus, and then in the second box, if I take out this 2x, I'm just going to be left with x squared, and then that's over x squared plus 10 to the second power. All right, so after I remove the parentheses or factor out the GCF, inside of this leftover part, I'm going to combine any like terms that we have. So if you look, you have a positive x squared and a negative x squared. So those plus 1 minus 1 are going to cancel. And that's going to leave you with, in the numerator, 2x times 10. So that's going to give you 20x over, so again, this 2x times 10 is combining together to give us 20x, because they're being multiplied, over x squared plus 10 to the second power. And that would be considered your simplified derivative.